Hello folks, in this video I want to talk about how we can take the equation of a quadratic function and turn it into its graph. We're going to do that by finding the x and y intercepts and then finding the vertex. So let's pull up an example here and get started. Alrighty, here's the example we're looking at. We're going to look at the function f of x is equal to x squared plus 3x minus 4. So before I'm even do anything when it comes to a sketch this graph kind of question, I like to just double check that I know what the graph kind of should look like in the first place. So what is the general shape of this graph going to be? So because this is a quadratic function, and again, quadratic just means that the largest power of x that you see is 2. And that's the case here. If there was an x cubed in there as well, so maybe x cubed plus x squared plus 3x minus 4, that would actually totally change the shape of our graph. But in this case, again, the largest power of x is x squared, and so that's what tells me that this thing is going to be a parabola. Now, again, you could have a parabola that opens up like a cup or down like a frown. And so the question is, which one is correct? So the way, or the characteristic that I would apply to that is, or sorry, the name I would use to describe that opening is its orientation. Okay, so does it open upward or does it open downward? So let's think about what we know about linear functions to kind of get an idea of this. And we did actually talk about this in a previous video, but I just want to quickly go over that once more. So if we look at linear functions, so a linear function is something like this, y equals mx plus b, where b is the y-intercept, so we know that. But check this out. Based on what the slope is, we actually know if the line goes down, or decreasing from left to right, or increasing. It'll go downward if its slope is negative, and it'll go upward, up and to the right, if m is positive, the slope is positive. So there's a similar effect when you're looking at a parabola. So in our case, the kind of analogous portion, or the analogous piece of that slope on a linear function is the a x squared term right here. So it doesn't look like there's anything there, but really that just means it's invisible 1, because it's 1 times x squared is what x squared is. So the fact that it's 1x squared and that 1 is positive tells us that it is going to open up like a cup. So we know whatever this graph ends up looking like, it's going to have this kind of shape. It's not going to be opening downward like a frowny face. Okay. Now that we've got that out of the way and we know what the graph should look like. Now, by the way, why did I do that? The reason is because at the end of the day, it should sit right. And if you can't tell if it sits right or not, well, you can't really tell if you're correct or not. And so what this does is it gives me some kind of, I guess, baseline or foundation for what the thing should look like. And again, you never know the final answer from the very, very beginning. But this gives you an idea if you got on the right track, or heck, even the wrong track. Alrighty? So if our graph doesn't end up looking like this, we'll know we messed something up. Okay, so we're going to find some of these special points that I referenced earlier. And what are those special points? So the vertices, the intercepts and the vertex. And I like to find them in this order specifically. So we'll start off with the y-intercept. Then we'll find the x-intercept, or intercepts, because we know a parabola could have more than one. And then we will find the vertex. Okay, so again, I'm going to make a big deal out of this, but it doesn't matter what type of function you're looking at. Heck, it doesn't even have to be a function. If you're trying to find the y-intercept, the first step is to set x equal to 0. Because whatever kind of graph you have, your graph might look like this. Oh no, big loop-de-loop. Your x-intercepts are at these points right here. Oh, sorry, y-intercepts are at these points right there. And at those points, the x-coordinate is 0. And so that's why we plug these in. And then once you do this, you solve for y. So depending on the equation, solving for y might actually be pretty easy, or it might be kind of difficult. In our case, this is actually not too bad. So f of x, or sorry, in this case, f of 0 is going to be equal to, let's remind myself what our function is, 0 squared plus 3 times 0 minus 4. Ready? What's really nice about these polynomial functions is that when you plug in x equals 0, pretty much all the terms are going to become 0, except for the constant term because there's no x there. And so f of 0 is equal to -4, and that's where our y-intercept is going to be. Similarly, to find the x-intercept, we're going to set y equal to 0. Again, for the very same reason, because whenever you're at an x-intercept, these three right here, for example, their y-coordinates are equal to 0 now. And we just have to solve for x. Generally speaking, this is actually pretty difficult, but this is why we spend so much time factoring, and you'll see why in a second here. So f of x, or y, is equal to 0, and we're trying to solve for x now. X squared plus 3x minus 4, right? Yeah. Okay, so this question on its own, this equation right now is actually not easy to solve the way it's written. I can't isolate the x like I would normally want to, or normally be able to, right? So let's pretend maybe I add 4 to both sides. So I'll add 4, and then I'll get, 4 is equal to x squared plus 3x. Maybe I could subtract 3x as well, so I'll end up with 4 minus 3x is equal to x squared. And so with this weird thing, you might want to take the square root of both sides to get rid of the x squared. And that would be totally fine, because on the right side you'll get x, but on the left side, remember, you have to take the square root of the entire side. Anything you do to one side of an equation, you have to do to the entire other side. And so what is the square root of 4 minus 3x? I really don't know. I wouldn't know what, I wouldn't be able to actually figure that out until I knew what x was. And so I could just maybe leave it here. But now you still have x on both sides and you can't isolate it. So that's not what we're going to do. But this is why we factored. So the reason we factored is because if I can, and this is kind of a general tip, if you're ever trying to solve an equation where one side of the equation is equal to 0, if you could turn this into some kind of multiplication problem, some kind of a times b, then you're golden, because all you have to do is find out what makes this piece equal to 0 or makes that piece equal to 0. Ready? This is why we spend so much time factoring, is because we know exactly what to do here to turn it into a product. Ready? So I won't go through that entire process here, but you should double check my work here, but this thing I believe factors into x plus 4 and x minus 1. And so, okay, well, if this product equals 0, then either x plus 4 equals 0, or x minus 1 is equal to 0, in which case you'll have x equals -4 or positive 1. So you have two solutions here. So what did we find? Remember, don't forget what you're doing. All this work was to find the x-intercepts of this function. So we have two x-intercepts right here. The last thing we can find is the vertex. And remember, the vertex, this is something that a lot of people forget. Remember, the vertex has two pieces. It's got an x-coordinate and a y-coordinate. It's a point on the graph, so it should have both. So to find the x-coordinate, remember, well, actually, let's just sketch what we have so far, and this will help, I think. So I'm gonna, again, a rough sketch. So here, something like this. Let's make that a little bit neater. Okay, so I have a y-intercept of -4. 1, 2, 3, 4. So that's my y-intercept. I have an x-intercept at -4. 1, 2, 3, 4. And an x-intercept at positive 1. Alrighty, so we know our graph is going to look something like this. And so where is the middle of this parabola, right? So that's where the vertex is going to be. And by the way, remember, we know the shape of this parabola opens upwards, so it's going to look something like this. We actually know that the y-intercept is not the vertex, although this is something that a lot of people want to do. I've seen people try to do this and then get it back up like this. But remember, a parabola is supposed to have symmetry. And so if you draw it like this, it's really not symmetric at all. Okay, so the vertex, wherever it should be right smack in the middle of these two x-intercepts. And it's a little hard to see where that is, but we could find it exactly, or algebraically, by finding the middle of those two numbers. So the x-coordinate of the vertex is always in the middle of the x-intercepts. Oops, sorry about that. Now, how do you find the middle of two numbers? Another way to find the middle of two numbers, or another way to say the question, is to say that you're asking for the average of those two numbers. And so that might be a little more familiar, in which case you add the two numbers and divide by the number of numbers you're adding, which in this case is 2. And so if we do that, that's going to be negative 4 plus 1 is negative 3. And then divide by 2 is negative 3 halves, or 1.5. And that's why we see that right here. Okay, so again, this is the x value of the vertex. But we need to find the y value. So how the heck do I do that? Man, if only there was some kind of formula or something that connects our x and y coordinates for this graph. No, wait. That's exactly what we were given in the first place, remember, folks. That's exactly what this equation does. Oops, this equation does. It says, hey, if you know what x value you want to plug in, this is how you get the y value. So let's just do that. And I'm going to use my handy dandy calculator here, by the way. So I'm going to evaluate f of negative 3 halves, or negative 1.5. Negative 3 halves squared plus 3 times negative 3 halves minus 4. And let's use a calculator because there's no reason not to. Negative 1.5 squared plus 3 times minus 4. And I get negative 10.75. Let me pause here just to double check I did that correctly. Yeah, okay, I knew something didn't feel right, so this is not right. Actually, it should be negative 6.25. Alrighty, so our vertex is at negative 3 halves, so negative 1.5, comma, negative 6.25, which is going to be right around there. So the vertex here, negative 1.5, 6.25. Last but not least, and we didn't say we were going to do this, but I'm going to encourage you to do it anyways. I'm a sucker for symmetry, and we have this point on our parabola right here. So I wish, and so like we have both x-intercepts, so they're mirrored. The vertex is unique. It doesn't have a second point that kind of mirrors itself because it is its own mirror point. But this one should as well, the y-intercept. And so where is its mirror image over here? Well, it's going to have the same y value because, again, it's symmetric. But how far away is it? Well, remember that this point right here, that line of symmetry is 1.5 away, 3 halves away. And so its mirror image should also be 1.5 away. And that's where that point is going to be. So this point right here would have the coordinates now. Let's see, 1.5 times 2. So that'd be 3 units away. So negative 3 with the same y coordinate, negative 4. This point is often called the symmetric point. It's really just the mirror image of the y-intercept. Strictly speaking, is it necessary? No, but I think it makes the picture just look a little more complete. And so this is the graph of this parabola. Ooh, not great, but here you go. This is the graph of f of x equals x squared plus 3x minus 4. Alrighty. So that's how you can take take an equation of a parabola and graph it. Now, by the way, this is really, really dependent on this function being factorable. Obviously, if it wasn't factorable, then you wouldn't be able to write it like this, and you wouldn't be able to find its x-intercepts. So in a later video, we will talk about what to do when that happens. Alrighty? Hopefully this helped. Thanks for watching, folks.